Right, welcome back students. So today I'll be doing 2.1b on understanding on differentiation, okay? And how is differentiation related to tangent of a curve? All right, so before I want to, it's going to be quite a challenging thing to understand lah. So hopefully you can actually follow along what I'm trying to explain to you. So we start first by looking at this diagram. You have a curve here, okay? You first have a curve here, then you have a line here. First of all, you must know what is the definition of a tangent. What is a tangent actually? Basically, tangent, right, is a straight line. It's a straight line. It's a line that touches the curve at only one point. So let me give you an example. If I have a curve here, and this is the line, is this a tangent? No. Why? Because it's touching the curve at 2 points. So how do I make this a tangent? Is this a tangent now? No, it's still 2 points, right? Okay, let me try to move it some more. What about now? Is it still a tangent? Tangent? No, it's still 2 points. So you must find a place, right, where it only touches at 1 point. If you see, right, this point. It's assuming it's touching at 1 point. So this is actually the tangent, which is what I've drawn up here. Okay, tangent can be tangent to the circle. Okay, you can have a circle, and then a tangent also. Tangent is basically this line. Okay, tangent is basically this point because it's touching at only 1 point. The straight line is only touching the curve at only 1 point, or the circle. It doesn't matter. Okay, so let me see. Let me ask you. Tangent is this line. Okay, tangent is this line. As you know, tangent is this red color line. Is PQ a tangent? Let me ask you a question. Is PQ a tangent? PQ is not a tangent now. What is PQ? PQ is just a line intersecting, means cutting the curve at 2 points. Okay, as you can see, it's touching the curve at 2 points. So what I want you to think of it is, right, how is this related to differentiation? You must understand that in this whole chapter, right, when we deal with differentiation, right, we are somehow dealing with gradient of tangent. Basically, right, we want to know what is the gradient of this tangent. Okay. Basically, in other words, how steep is this tangent? How steep it is? Tell me a value that I know how steep is this tangent. Maybe, I say this tangent is maybe 2, or roughly I know it's a positive tangent, is moving in a upwards direction. So I know the gradient of tangent. But how do I calculate gradient of tangent mathematically? Okay. As you know, as you learn in your maybe, I don't know, you learn in your Form 2, Form 3, I'm not very sure, or in your IGs, whatever it is, that to calculate gradient, let's calculate gradient first. You have the formula of y2 minus y1 over x2 minus x1, correct or not? Y2 minus y1 over x2 minus x1. But the problem now is, what is the problem now is, this tangent has only 1 point, you know. We don't look at PQ now, we look at the tangent, which is the red color line. You only have 1 point. So you only have one coordinate. How are you going to solve this equation? Because this equation will need you to have x1, y1, and x2, y2. Basically, 2 sets of coordinates. You understand? But this gradient tangent, you only have 1 coordinate. So there's no way you can substitute 2 coordinates. So what we do is, right, I want you to teach you an understanding of what they did, okay, to this thing. So they look at PQ first. So they know that they understand, the mathematicians or whatever it is, they really understand that, there's only 1 point which I cannot do anything much about it. Because 1 point I cannot substitute in this formula. I need 2 points to substitute in this formula. Okay? So what I do is I look at PQ first. Look at PQ. Okay, look at PQ. PQ is this thing, and I label their coordinates. Yeah. So how I label their coordinates is I label XY here. I label XY here. And then here I label as X plus delta XY plus delta Y. Why X plus delta XY plus delta Y? Because delta basically means a small change. Basically means small change. Okay? A delta basically means small change. So you know that this is XY, and this point, right? This point here, right? This point here, this point Q, it's like delta X away from here. You see not? Because it moved delta X to the right, and then it moved delta Y to the top. only it reached Q, right? So it's like it has a slight change in X by moving to the right a bit. Then it has a slight change in Y by moving above to point Q. That is why it arrives to point Q. You see, not that's why it moves to the right a bit, it moves to the top a bit. You understand? If it didn't move, it would stay at P. Agree or not? Just because it moved, that is why it moved to point Q. So what is the movement? Is the change in X and the change in Y. So I can label this one as X plus delta X, Y plus delta Y. You understand what I mean? So once you understand why is it X plus delta X, Y plus delta Y, now we substitute into the formula because now we have coordinates for both of these two pairs of coordinates. And I teach you one way later how they can get dy dx, how delta y delta x gives you dy dx later on. So we apply the gradient formula. Gradient of PQ is y2 minus y1 over x2 minus x1 as I've discussed here. So now you have two pairs of coordinates. The first pair is xy, which is your P. And then now you have your Q, which is x plus delta x, y plus delta y. As I say, y you plus and plus delta x and plus delta y, because this set of coordinate is somewhere higher and somewhere onto the right. So I plus a delta x means what do you mean by delta x? Means it has a change in x. Basically, this x, this px, this coordinate p, the x, you move a bit. So you have got to add that bit into this x to get this new x. You get what I mean? Because it moved to the right one. So you got to add how much it moved to the right. I'll label it as delta x. Okay, and it moved to the top. How much I have to add? I add delta y lah. I don't have to know how much first. I just add delta y. You get what I mean? Because there's a change in location. That is why I add delta x, I add delta y. Alright. So now I have two coordinates. What I do is I use the gradient formula. What I get is I assume this as x1, x1, y1, x2, y2. Substitute in the formula. y2 minus y1. y2 is y plus delta y minus y1, which is y. Divided by x2 is x plus delta x minus x1, which is x. Okay, once I've reached this stage, you realize that the y and y will disappear later, the x and x will disappear. I will be left with delta x and delta y. Delta x divided by delta y. Okay, so delta x divided by delta y is basically the gradient of this line PQ. What does this delta x delta y represent? It represents gradient of line PQ. Do you agree or not? Because this is where we originally start from. We started from gradient of PQ. We want to find what is gradient of PQ. Okay? We slowly move from gradient of PQ to gradient of tangent. You must understand that this whole subtopic is about finding gradient of tangent, which is the red color line. But we cannot find it straight away. So we start from PQ, then we move it to the tangent. I'll adjust certain things so that the PQ becomes the tangent. Okay, so now I found the gradient of PQ already, which is delta y delta x. So now how do I get gradient of tangent? I want gradient of tangent, I don't want gradient of PQ. You understand what I mean? So how do I get gradient of tangent is, what I do is you imagine, I want you to imagine certain things. Imagine that this line, right? Imagine that it's a bit messy here. Let me redraw something down here, since there's space here. Okay, imagine now, I have this point, this is a fixed point. This is PQ, okay? This is PQ. Okay, this is the tangent I want to find. Okay, this is the tangent. Tangent at this point. No, actually, this is quite ugly. Let me just say this point. Okay, this is the tangent I want to find. Okay, the tangent I'll label in black lah. Okay, this is a tangent. Okay, this black color line is a tangent. Okay, so how can I move from PQ? As I said, this one PQ is this one. How do I move from PQ to become the tangent? How? Okay, so what I do, right, is I'll try to, you see, it is separated by delta x, right? We just look at delta x. This is delta x. Basically, remember I told you, if this coordinate is xy, it has a slight changes in the x location. It is more towards the right now. This point Q is more towards the right. So I have x plus delta x, and it's relative to point P. Q is also above point P. So y plus delta y. Okay, so what I want to do now is try to imagine what if this delta x becomes smaller and smaller? What do I mean by that? It's smaller and smaller means the Q is sliding towards P. You see, it's sliding towards P. What do I mean is that you see instead of PQ here, right now the Q slides below. Now it reached this point. Now it reaches this point. The delta x is smaller right now. I want to label again. Okay. Can you see now? The delta x now is smaller. This gap is smaller now compared to the gap just now. The delta x is getting smaller and smaller. Now my idea is I want to force the delta x to be smaller and smaller and smaller and smaller and smaller, so that this point will keep approaching. You see, now I approach this point now. Now the delta x is even smaller. Now the delta x is even smaller. The length is just this much only. The delta x is just this much compared to originally it was this far. Then it became this far. You see now the green to the blue to the brown is getting shorter and shorter, which means actually the point, you don't have to really understand it, just probably get my idea of it. So which means the point is actually sliding towards what? Sliding towards this point here. You understand what I mean? So what happens when this delta x approach 0 means this delta x will keep sliding until this point, will slide until this point, until this black point. Means delta x now there's no delta x. It means like this point Q, right, is something like moving downwards along the slope until it touches point P. Now point Q is also here already. You understand? So until that point, right, we will know that these 2 points, right, imagine if you have got a point, if you have got a point, right, okay, I wrap off this one because it's very confusing. Imagine, right, it keeps sliding now, it keeps sliding now, it keeps sliding down, it keeps sliding down, it keeps sliding down, it keeps sliding down until there's one point, it keeps sliding down, then it forms different gradient. This PQ gradient will be this one, will be this one. Oh, it's very ugly. I don't think I can draw this. Let me think how to draw. I know what I can do already. I tried to draw a more curving. Okay, so the tangent is here. Tangent is here. Okay, so originally it's this line. PQ is this line. Okay, PQ is this line. So what is the Q slides downwards? How does the Q slide downwards when the delta x becomes smaller? When the delta x becomes smaller, it will slide downwards. It will slide downwards to become maybe this point, just say. So this is the new PQ gradient. Okay, this is the new PQ gradient. I draw again this thing, so it's nicer. Okay. Okay, so this is the new PQ gradient. I'll draw Q prime here. Okay. Then now what if slide down some more? Slide down some more. I use green. Slide down some more, maybe somewhere here. This is going to be the new so when the dx is even smaller, do you see now this green color line, right, is actually getting nearer and nearer to the tangent already. Actually, our idea, right, what we are trying to do, right, from the red line to the black line to the green line, what you're trying to do is, right, we're trying to make dx, we are trying to make delta x smaller and smaller and smaller, and it moves smaller and smaller and further and smaller some more and further smaller some more until y. Why are we doing it? Because when the delta x, once it approaches 0, smaller and smaller until it approaches 0, it will give you the gradient of the tangent. Because you see now, from this first line to the second line to the third line, do you agree that these 3 lines are slowly moving to this tangent line? You see now, if they continue to move downwards, you form this line eventually. That is the idea of differentiation. You get what I mean? You try to slide the Q downwards, slide downwards, until at last, when you slide until maximum, it will form a tangent. That is the idea. Okay, so when dx it approaches 0, the gradient of, you must understand this, the gradient of PQ is actually your gradient of tangent. Basically, the Q, right, will be somewhere very near this point, very near the point P. It is somewhere maybe here, point Q. You see this line, you see now, I don't know whether you can see now. Okay, maybe this point Q and point P is here. So you see now, they are so close now that this gradient, right, let me show you the line here. Can you see the line here? is actually in this tangent line already. So the gradient will be the same. So we have found the gradient of tangent. I don't know whether you understand now. Basically, is that like you want to slide the q down until the delta x becomes 0. Okay, don't forget when you slide the q down, the delta x becomes smaller and smaller and smaller until the point q is so close to p, right? Delta x is almost 0 already. They are so close to each other that the gradient between them is actually the gradient of tangent. I repeat it one more time. At first, q is on top here. Q is on top here. As you slide the q down, what happens is the I write down, as you slide the q down, I'll explain to you. As you slide the q down, the delta x becomes smaller and smaller until the delta x becomes so small until the q is like next to p. The q is like here, this q is next to p until the gradient between point p and point q, you might not see the line because it's so close. The point p and point q, the line between them, right, the gradient is actually the gradient of the tangent already. That is the understanding. Okay, so actually the idea of finding the gradient of tangent is to find the gradient of PQ when delta x approach 0. Approach 0 when it's so close. Approach 0 means the Q is so close to P that when they form a line between them, that gradient is same as the gradient of tangent. I hope you listen to what I'm saying. So I'll try to write down. Okay. So as delta x becomes, I'll try to write sentence down for you for your understanding. Smaller and smaller. Okay, what will happen is your delta, your Q will slide down the curve and getting closer to P. You understand? Okay, and you must understand when it gets closer to P, right, the gradient also will get more accurate and more accurate to the gradient of tangent because it's moving to the gradient of tangent. The gradient of tangent is like this. You are like this. You are slowly moving until you are actually on the gradient of tangent. You understand what I mean? So the Q will slide down to the curve and getting closer to P. So when delta x, because when delta x becomes smaller, it will slide down. So when delta x approaches 0, point Q will get so close to P such that the gradient of PQ now, you see this P and this Q, what I mean is they are so close now that the gradient between them, the gradient of the line between them, the gradient of PQ is equals or is approximately equals to the gradient tangent. Okay, so we have a notation for this. This is what it means when you see something like this. When you have delta y over delta x, this is actually your gradient of PQ. If you refer to your graph, gradient of PQ. Okay, when this delta y over delta x, when delta x approach 0, remember I told you when delta x approach 0, then the gradient of PQ will get so close, the Q will get so close to the P that the gradient is actually now gradient of tangent. You can actually rewrite it as a very special dy dx. This is actually gradient of tangent. This is gradient of tangent. Gradient of tangent. It will give you this thing. Okay, when delta y delta x approach 0, when delta x approach 0 for delta y over delta x, it will give you gradient of tangent. What is delta y over delta x is gradient of PQ. What is dy dx? Gradient of tangent. So how are they equal to each other? Only when delta x approach 0. You understand? When P and Q get so close, as I mean, Q at first is on top. Now it moves closer and closer and closer until they're so close. When approach 0, they're almost like 1 point already. And the line between them, the gradient, is actually the gradient of the tangent. You can imagine it is a good thing. If you cannot, also never mind. Try to understand it. You understand? So this is actually your understanding of differentiation. Basically, we know how to find delta y delta x. Delta y delta x basically just normal gradient. Just normal gradient, okay? But how do I find dy dx? Is when delta x approach 0. That's the extra thing that you learn above what you learned before this. Okay, delta y delta x is between P and Q. basically between 2 points. But now we want to find gradient of tangent. So we make delta x approach 0. And the understanding is what I told you just now. As q moves closer and closer to p, you'll realize that they actually form a line between them, that the gradient is actually the gradient of tangent already. Because they're so close now, q and p. That is the idea of gradient of tangent. So this whole chapter, in fact, after we learn the techniques of differentiation, in 2.2, we will do a lot of gradient of tangent, gradient of blah, 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 all these kind of things, basic gradient function, gradient of normal, equation of tangent, which is very simple. Very, very simple, I promise to you. You understand what I mean? Right? So this is the understanding for how to understand gradient of tangent to the curve. Okay, so if you have any questions, you can always ask me again in the comment section below, because I'm not really a maths professor or whatever it is. I'm just a person that think I can help you out, so I'm trying to teach you. Okay, so I might make mistakes, or if you're a teacher and you see I'm making mistakes, doesn't matter. You can just always comment down and let me know, so we can learn together. Okay, other than that, I hope that I can bring to you some knowledge on this gradient of tangent and how to understand this, because usually people don't understand. People just straight away go and apply formula. Okay, which I don't want you to do lah. So this is actually your gradient, your gradient of tangent understanding. That will be end for this subtopic in this 2.1 part B. Right. So with that said, I'll end this video and we see each other in the next video.